Hi, everyone. Welcome to Project Invent's 2026 Virtual Demo Day. My name is Amanda Nepomuceno, and I'll be your MC. During this event, you'll hear pitches from teams of empathetic, innovative, talented students from across the country who have created inventions for social good. They've interviewed community partners, identified challenge areas, and have built original inventions with the goal of helping solve real-world problems. Through Project Invent, they're empowered to innovate and become change makers, leading with creative confidence, empathy, and ambition. And we would like to welcome all of the teams today from the following sites who are joining us today. All right. And would love it if everybody could engage, but as soon as I call your school name, if you would like to give a virtual clap or virtual emoji, please feel free to do so. But we would love to welcome the students and educators from Provision Academy, Zebulon Middle School, Apopka Middle School, Lawrence Middle School, Stephen M. White Middle School, and East Wake High School. Also, before we start the pitch portion of the event, we want to take a moment to shout out some of the incredible educators that are on this call today, because without them, this wouldn't be possible. So I would first like to start with Provision Academy. So thank you so much to Miss Andrea Pipkins, as well as we have on the call Mr. Charles Sadberry and Mr. Larry McKenzie, as well as April Tasso. So thank you so much. We're grateful to everybody at Provision Academy for their leadership and support in Project Invent and for empowering all of our lovely Provision inventors. All right. So second, we also have here educators on the call, educators from Stephen M. White. So our three educators from Stephen M. White have co-led Project Invent for the entire grade. They've allowed them to utilize each of their expertise to facilitate different parts of the design process. So thank you so much, Mr. Medrano, Mr. Sekijima as well. We also have on the call Tori Silvestre. So Tori, thank you so much. You have dived headfirst into this process and incorporated your own style, skills, and pizzazz to inspire students to invent openly and creatively. Awesome. We also have Mr. Eric Matsubayashi. Eric, you've gone above and beyond for your students, really ensuring that they drive the learning in your class, but also that they get the opportunity such as 3D printing and live pitch coaching opportunities. So thank you so much, Eric. We also have Jamie Balagot. So Miss Balagot balances many priorities with her project invent work and yet has prioritized learning with her students so as not to rush the experience to say it was completed. Thank you so much, Miss Balagot. And we also have Miss Jennifer Melton. Miss Melton, you have made this work meaningful for your middle schoolers by meeting them at their level and pushing them to do innovative things and to think outside the box. So thank you so much. And I also see again, Mr. McKinsey from Provision is here. Thank you so much, Mr. McKinsey, for being flexible and collaborative with us in this pivot. We appreciate you and Mr. Sadberry and April Tasso so much. So why don't we give a round of applause again to all of our wonderful educators that are on the call today. Awesome. All right. Well, we are going to get started with our pitches, everyone. So now it's time for teams to break up in their pitch rooms. So how this is going to work is that we have so many schools on the call today that we can't fit you all in one breakout room. So according to this slide, you're going to be, please join the breakout room. So my colleague Madison is going to open 3 breakout rooms, as well as, and once you're in your breakout rooms, when the pitches begin, each team of students will present, or we will be playing your 5-minute pitch, followed by 4-minute question and answer with our lovely judges. And then afterwards, once we get through all of the pitches, the judges will go off and deliberate, while the rest of us will be able to come back into the main room and listen to our very inspirational keynote speaker. All right, so it's time for teams to head to their breakout rooms. So Madison, do we have the breakout rooms ready to go?
Yeah, so to our room one participants, if you are able to all hang back in this main room, that's going to be our room one. And then when I open up these breakout rooms, you are going to see pitch room two and pitch room three listed. So that's going to be for our room two and room three teams. We can go ahead and hop in as soon as I press open. All right. There you go, everybody. And judges, you should see that invitation appear right there on your screen to go ahead and join.
Madison, which room I'm in again?
Prasanna, you are going to be in this main room, pitch room
Main
one.
room. Okay.
So,
All right,
yeah.
cool. Thank you.
All right, everyone. So just let us know if, again, you have challenges getting to your breakout room, we'll be able to help you all. But for those that are here, we're going to get started soon. We're so excited to have all of you here. All right, room two. So if you're ready to get started, can you all give me a thumbs up?
Hey, Amanda, this is
Hi.
Eric. How are you doing?
Good, Eric. How are you?
Great. Say, so I spoke with Jerome yesterday, and he said that we are going to be kind of in the later part of the presentation. So my students are actually right now, they won't be able to attend until like around 10:45 or like 10:30. So Paul Revere, is it okay if we kind of get pushed to the end? I think that's what Jerome said, that we'd be pushed towards more the end. So our students, is that cool? All right, cool. Just wanted to make sure because I have no students here now. So it would just be you guys staring at me all day long. So appreciate you guys.
No worries, Eric. And thank you so much for joining early. So if that's the case, like we'll just put you guys once the students come on, okay? Awesome. Well, I see we have Lawrence Middle School here, and we have Zebulon Middle School here, so we're so excited to get started. Students, can you all give me a thumbs up if you're ready to get started? All right. Thank you so much, Zebulon Middle School. And I hope our East Wake students. So I think East Wake is actually in room two. So I'm going to put you in room two. And otherwise, let's get started with our pitch room one, everyone. All right, so now it's time to meet our judges. So, judges, if you could give a wave to everybody that is on the call. We're so excited to have you all here. So, we have Mike Catterlin and we have Prasanna Babelshwar. So, I am going to first introduce you, Prasanna, and then Mike. And then after I introduce both of you, would each of you please share what you're excited about for today's demo day? All right. So first, I'm really excited to introduce Prasanna Babelshwar. So Prasanna is a technology leader at Atlassian with 23 plus years of experience in enterprise platform engineering, intelligent automation, and AI-driven product development. At Atlassian, he led the vision, architecture, and delivery of the talent acquisition technology platform, serving 10,000 interviewers globally. He holds a Master of Science in Computer Science from Georgia Institute of Technology and has authored patents and published peer-reviewed research at the intersection of AI, machine learning enterprise, software as a service, and data engineering. So well, let's give a round of applause to Prasanna, everyone. And Prasanna, please share what are you excited about today?
Hey, thank you, everyone. Thank you for joining. I'm so impressed by all the team names I saw in the introductory slide. I'm super excited to be here, to be able to see what today's new inventors are thinking about and what is the problem that they're trying to solve. And if I can add one or two feedback or sort of steer them in a direction that they can succeed, that I consider as a very successful day for me today. For definitely, I'm very excited to be part of this activity. Thank you.
Thank you so much, Prasanna. We're so excited to have you here and welcome. All right, and now I'm also excited to introduce Mike Catterlin. So, Mike is an operations manager with experience in design, prototyping, production, and service, with an emphasis on operational excellence. He oversaw the design, build out, and management of 12 makerspaces, not only in the United States, but also overseas. So he is so passionate about empowering students, elevating local artists, and transforming communities. Mike graduated from Santa Clara University with an MBA. All right, Mike, so what are you excited about today?
Hi, everyone. I'm super excited to see how teams have worked with their community partners to identify needs and come up with innovative solutions. Throughout my career, and especially at the makerspaces, I've seen hundreds, literally hundreds of ideas go from idea to prototype. And the ones that have always been the most successful are the ones that are working with real people and solving specific problems. So I'm really excited to see how our young inventors, how the Project Invent students have done that, and how you've worked to become empathetic problem solvers, because that's where you really get transformative things for individuals and for communities.
Awesome. That's amazing, Mike. Thank you so much. So, Mike, Prasanna, again, and students, why don't we give them all a round of applause or a heart? And thank you so much for taking the time and for lending your time and expertise to us today. All right, so we are going to get started with our Lawrence Middle School students. So, Lawrence Middle School students, I'm going to play each of your pitches, your pitch videos, and then we're going to open it for Q&A. But first, we are going to start with Team Battle Bots. So, Lawrence Middle School, are you all ready for us to play your pitches? If so, you can give me a heart or a like. Awesome. Thank you so much. Okay, so I am going to go to our videos. All right, everyone. So it is my pleasure to introduce our first team, Team BattleBots.
Robot project in Alex and Ken.
We can try to make a robot that can move around a area and it can try to find stray animals. Our second idea is a automatic feeding dispenser that gives dogs the right amount of food.
Our third invention can be whenever someone gets a dog, we can install a camera just for the dogs so they don't get mistreated. And an add-on, you can put a door lock for when they get abused.
The idea we are most excited about is the robot that can try to find stray dogs.
The way the robot will work is it will find stray animals and it can give them food so it can survive until someone adopts them.
The invention would look like this, but it would move and would give food out, but it will calculate how much food to give out.
The way it will impact is it will give them food to survive, and it can show where the stray animals is located.
She said that she liked the idea of invention too because most dogs are overweight or they eat the wrong amount of food. So we wanted to make something that gives them the perfect amount.
All right, let's give a round of applause to our students, Team BattleBots. All right. All right, so judges, I'm going to hand over the mic to you for your questions.
Go ahead, Michael.
Hi, team.
Hi.
My first question for you is I'm very curious of your name. Is the robot going to battle the stray animals? Why BattleBots?
We made it BattleBots because it would go on wheels to find things, and like if anything, it could like move stuff out the way, like just in case.
I see. Okay. And did you all, I wasn't clear from your slides or your video, did you all, was it more of the idea for the robot, or did you all get a chance to actually try and like make any of the parts of the robots or any of the sensors? Did you all work with Microbit Arduino? Or did you make any part of it? Or is it more of the idea?
Your prototype. Huh? Your prototype. Uh, wait, what? Yeah, we made the prototype. Yeah, but it's called. So I say we kind of lost it. What's it called? We lost it, but I don't know how. Yeah, it just went away somehow. See.
Oh no, I'm so sorry to hear you lost it.
Yeah, we tried so hard on it.
Do we need another idea to find a bot? We need another bot now.
Yeah, we do.
Sure. All
Alex,
the
how
best.
far did you get with your bot? What could it do before you lost it?
It could dispense food for the dogs, like the stray animals. It could dispense the perfect amount for them. To reduce obesity, so the dog can not be like really fat.
How do you plan to improve it further on your prototype?
Say that one more time, please.
Yeah, sure. How do you plan to do you plan to add more features to it,
Yeah,
to your
yeah.
prototype? What more features? What do you think is missing in that?
Well, like it wasn't like very specific with the amount. Oh, what we could add is like maybe we could add some wheels to the bottom so it could like go. It could drive on its own to find like the stray animals, so it could dispense them the perfect amount of food.
Yeah, and also give some exercise to the animals. maybe a ball thrower.
Be here.
Thank you.
Maybe a locator. My last question for y'all is did y'all think through how your robot would know how much food to give? Because I think if you're finding stray animals, you might find a small dog and maybe a large dog, and they have different food needs. So did you all think about like how would the robot know how much food to give as you think about the obesity issue?
Yeah, we were gonna also apply a scanner, so like it could just scan the kind of dog type, and it could either give it like the kind of food it needs, or like it could give an amount that the dog usually would eat on it.
Okay, cool.
Awesome. Thank you so much, Team BattleBots. Everyone, why don't we give them a warm round of applause? Amazing job. Thank you, students. All right. So now we are going to go to our next team, Team Pip Kiwis. PP Kiwis. All right, Team PP Kiwis, are you all here? Hi, everyone. Awesome. Welcome, welcome. All right, so I am going to share my screen and then we can get started.
Hello, we're the inventors of PP Kiwi by Jonathan, Jose, Andrew, and Damon.
Hannah Lentz is the executive director of the company named Spark, supporting people and animal relationships for change. And she has asked us for help about how she sits down too much at her chair and she needs more exercise.
The big problem. Hannah needs to stand and walk more. And also, Hannah doesn't have much time to do those things with all the people that she meets on her computer a day.
These are our 3 ideas to help her. Damien Demi created a pacer that counts how many steps she takes and reminds her how to exercise and move. Jonathan made another idea called the butt massager, and Andrew and Jose created an LED screen that spells out when she needs to exercise and also works as a digital calendar.
Our top idea and quote from partner. Hannah Lynn's quote. My lower back hurts from sitting down a lot, and I also feel something a bit silly can motivate me more. We all voted, and the idea that had the most votes was the butt massager, and was liked the most by Hannah Lynch.
How might the butt massager work? The butt massager will look like a regular seat cushion, and it will have a button on the side that you can set how fast it vibrates, and it will also have a mechanism where you press a button and the mechanism will push up and down.
The novel. How our idea is similar to the market. Our idea is similar because it helps with lower back pains from sitting a lot and soreness, and it's different from the market because our product is a bit different because it also massages the lower back, just not the butt, with small lower backrest on the machine.
Our community that we are trying to help is Spark, and we are trying to help Hannah Lynch so that she can do work on her computer and meet people through Zoom more comfortably.
Hope we helped.
Hope we helped.
Awesome job,
I need,
Kiwis. Okay, Prasada, Mike, go ahead.
yeah, I need one right now. Can you ship it, please? All right. Do you have a prototype by any chance? Do you
Yeah.
have you worked on? Yeah, go ahead. Oh, wow. Nice.
It's right now. It's like we didn't have like material, so we just used what we had. And it was like a prototype of like cardboard, and we like tried our best to like make a replica of it. Yeah.
Okay.
Is that cardboard prototypes are a great way to start. Like it's simple, it's fast, it's a good way to test it. So that's awesome. Is that the ultimate size of it? I think it was supposed to be a button masher and lower back. Is that right?
Yeah.
We just need to make it a little bigger.
Yeah.
Okay. Team, I wanted to say, great presentation. I think you did a really good job of like saying exactly who your community partner was, the need. I think also I really appreciated the quote you added, how Hannah was looking for something silly, and that's one of the reasons you ultimately got to the butt massager, which made me laugh. So I think that was really good. I think you guys did a great job of finding a need. I'm curious, so this is your cardboard one. It sounds like you were building something else. Were you able to, maybe it got lost or some of the parts I'm just curious of like if you got it working at all, or what were some challenges you faced while you were building your prototype or prototypes?
Like it wasn't like
it kept falling apart.
Yeah, it wasn't stick together.
Oh, okay.
But like we use like a different way of like attaching it, and like it seemed to work.
What was doing the ultimate massaging? And was there like a sensor in there? How would it know when to massage? Would it massage all the time? Would you have to turn it off and on by yourself?
Yeah, it was like there's
buttons on the side of it that you can press and turn it on or off.
Okay. And what was doing the massaging?
There was like blocks, kind of like a bunch of massage guns. Yeah.
Okay.
And it was like there was like, or like we tried to make it like a computer inside that was attached to like the buttons, and like it would like control the speed. Yeah, the massaging.
Okay.
Any other questions? Show it. Yeah.
What did you learn from this project?
The drawings. All right, my bad. Andrew, what we that there's a lot of challenges in trying to doing something, but there's always a way to like solution. There's always a solution to like make it possible. And you just gotta like keep trying, like you could learn from those mistakes.
Nice. Did you do any research in your when you are creating a prototype or when you are designing a solution? Did you do any research?
Yeah.
What did you learn?
Like the design, you see how like what the most popular designs, but like we try to make it like our own.
Mm-hmm. Cool. All right. Thank you.
Awesome. Thank you so much, Lawrence Middle School students. Let's give our Lawrence Middle School students a warm round of applause. Thank you so much. All right, team. So now we are going to move on to our students from Zebulon Middle School. So Zebulon Middle School students, are you all ready? We're going to play your pitches. Awesome. Hi, Miss Melton. All right, so we are going to start with our first team from Zebulon Middle School, Team Bo 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 Bot.
The Bot by Charles Davis,
Pierce Smith,
Ronald Don, Dakota Pulley. We are Team Bellberry Biscuits from Zebulon Gifted and Talented Magnet Middle School, Center for Advanced Studies and STEM.
This is our community partner, Simon Warren from Durham County Water Facility. Durham Water Facilities is losing water, and there's no device that can help track or find leaks quickly, so they don't lose water. In our meeting with Mr. Warren said that more water was leaving the facility than was being used. When they lose water before it gets to the customer, they are spending money on chemicals to treat it, and that water is not reaching the customer. They are taking a financial loss, and they are losing about 4 million gallons.
We designed a robot that helps us find leaks and quickly maneuver through the pipes. It shoots out a flexible sealant that will help us stop the leak, so Durham Water is losing less money and less water and therefore less money. Introducing Bobot. And here's our demo video. Our product includes features that are very simple but have a big impact on helping us identify water leaks. A sound sensor to listen for water leaks, an acoustic leak detection that uses a very sensitive microphone on to hear hissing water, and once it identifies it, it shoots a flexible sealant that is a temporary seal if the leak until the maintenance department can find a permanent solution.
User testing. Being that this is a demo project, this is not waterproof. We could not test this in an actual pipe. If we were able to test this robot, it would indeed be waterproof and we would be testing it in a pipe to see how it works. We are stimulating a water leak by using a blue Lego to serve as the water. The robot would identify the leak and then set off an alarm to highlight the leak. Once the leak is identified and acknowledged, the robot would shoot a sealant over the leak to stop it immediately. Competitor Matrix. Name of the product is the Bobot microphone, to detect water leak sounds, sealant to shoot out and fix the leak, camera to visualize what is happening in the pipes. The estimation of the price is around $3,100. Then we have the JQK JCam. This gives live footage of the pipe, and it's about $800. After some research, we found some products that are similar to what we are doing, which is the JQK JCam, and that spans 25 to 50 feet, provides live footage of the pipe. However, this is not really effective, and it does not have a sealant to shoot out and fix the leak. Next steps. If we have the ability to build a real prototype, these would be our next steps. Build a waterproof prototype to test, testing our prototype in different sizes of pipes, adding a camera to show what is happening in the pipes, and creating a device, arm, that will actually shoot out a sealant material that will stop a leak.
The whole team took the time and effort to make this, so we really hope you enjoy it, and thank you for listening to our presentation. Thank you.
Awesome. Thank you so much, Team Bobots. All right. So, Mike, Prasanna, take it away.
Thank you so much. This is a real problem. Thank you. I mean, I live in Dublin, California, and we always have a water problem every summer, and this is very close to my heart. And I come from India, and I hope you might have already seen that there are a lot of water problems in most part of the world. And what problem you're solving is very innovative, and I really like the problem that you have approached, the way that you presented, and the cost estimate you provided is also very spot on. I really liked it. Just wanted to check what challenges did you face? I saw a little video of a robot, that prototype. What were the challenges when you started making those prototypes?
So some of the challenges that we faced were really just coding it because
Okay.
an error happened where everything just kind of stopped working and then it just started spinning around every time we tried to make the robot.
Oh no.
That's right.
And so, oh, perfect.
Sorry.
Were you
Now we can see all of you.
were you coding the robot for just movements? Were you able to try and like incorporate your acoustic sensor to detect the leaks?
Yeah, actually, that is what this little camera right here is for. It will detect the blue color right here. It'll detect the blue color
Nice.
water droplets that you saw in the video, and it
Okay.
will make noise, and then hopefully in the future we can make it shoot out a sealant.
That's awesome. That's great. I heard you on the next steps of like needing a waterproof prototype. Great identification. I'm curious, what is the vision for your kind of next step? Is the robot, would it operate inside? Like, where are the leaks at, I guess? Are these like underground pipes? Are these pipes in buildings? Like, where is it looking for leaks? And then how does the robot navigate that space? If it's like in a pipe or if it's around it? Just curious how that worked, or what maybe you heard from your community partner.
Well, we heard that the pipes were inside. Underground. So there would be like kind of like train tracks, kind of where it would scale across, like scanning with the head that's right here. You're scanning across and checking for leaks every 30 minutes, right? Yeah, kind of like that. And between that, we would use that and it would send alert to like the person who the computer that the leak people
The people that would actually like fix the leaks.
yeah, so it would use that and then the track would be how it kind of navigates the pipes that are underground.
So it'd be on, oh, I'm sorry. So it'd be on tracks underground, like next to the pipes, like outside of the pipes?
Yeah, kind of next to the pipes.
Okay. Yeah, maybe something to think about if you go into the next step is maybe getting a little more information on like what is the setup for the pipes. I think a lot of times they'll put a pipe in the ground and then they'll just backfill with dirt. So it'll be kind of like buried and surrounded by dirt. So I don't know if you'd have the space or the ability to put tracks, and so that might influence your design of your robot. Of do you need a different way to navigate, like maybe inside the pipe, and a way to detect that way? Did you get a chance to test your acoustic detection device? Because I do think it's a very innovative way to try and do the leak detection.
Yeah, in our presentation, actually, there was a demo video where it did, I don't know if you could hear it, but it did make the noise, and then we had a little thing where it would make a hissing noise as in shooting out the ceiling.
That's awesome. That's great, team.
We're done with the questions, I think.
Oh, I have one more question. At your beginning slide, you said they lose 4 million gallons. Is that per month, per year? What's the, do you know, 4 million gallons what?
It was 4 million gallons per year.
Per year. Okay. Awesome. Great job, team.
Thank you.
Thank you.
Awesome job, Team Bobots. All right, now we are going to move on to our second team, Team Leak Hunters. All right, Team Leak Hunters, where are you all? Awesome. Welcome, everyone. So I am going to play your pitch video now. Are you all ready? Can you give me a thumbs up? Amazing. I see you brought your prototype. Amazing.
There we go. Okay.
Where
are the leak hunters?
Meet Team Leak Hunters, Thomas Evans.
Wyatt Wright.
Elijah Roberts.
Daniel Kinney.
Alana Perry.
Our community partner, City of Durham, Department of Water Management, point of contact Simon Warren.
Mr. Warren explained they know how much water leaves the facility and how much is being used. Not all water leaving is accounted for. 1,460,000,000 of water is lost a year. That's 5 billion gallons a year.
Introducing our product, the Leak Hunter, a submersible robot designed to detect and fix water leaks in the pipes.
Our solution is the Leak Hunter, a submersible robot that uses audio sensors and a camera to sense leaks. It will then spray out flexible sealant to stop the leak until a more permanent solution can be used.
I think that they should buy our product because our product would help them fix the leaks and they will be losing less money.
Our cost in production would be around $846, which for our product would be around $1,000 to $2,000. This is our demo video of the Leak Hunter.
Competitor. This is our Roto-Rooter, which has a long line and so it can sense the water.
User testing. We need to make sure that all the important parts of our robot will work because if it doesn't work, it would be a big waste of money.
Oh, we would like to change the material and improve the coating.
We would like to make it smaller so it can fit in the pipes.
We would like to improve the arm part of the machine.
We would like to code the camera in front to make detecting leaks easier.
The end. Thank you for letting us pitch our product, the Leak Hunter. Thank you.
Awesome job, Team Leak Hunters. Amazing, amazing. All right, Mike and Prasanna, take it away.
Yes, we have a good competition here. Looks like you guys are solving the same problem. How did you compete with the other team?
Yeah, we don't really compete.
We don't compete.
Sorry, come again? I didn't hear that.
Oh,
We don't really compete.
yet.
Oh, okay. All right. Cool. Just one question. Did you mention that it was the robot goes inside the pipe?
Yes.
I think I'm pretty sure we did. So we're not actually gonna add the wheels to the machine. This is just so we could show the video. And
Right,
it's
right.
and the motor on the back
Mhm.
where it can, go through the pipes.
I see.
And that's what our actual product will look like.
Can you hold it? Can you hold it a little bit closer to the camera? I just want to see that. Oh, okay.
It's close to what it will look like.
Oh, interesting.
Oh,
So
okay.
this sort of floats on the water in
Yeah.
the pipe. Okay, that's the idea. Okay, nice.
Yeah, that's great, team. So it seems like your robot was kind of a proof of concept of how it would navigate. A great job with the robot. I love the little arm that came down for the sealant. And it seems like your white looks like a 3D print is kind of what the ultimate platform you'd like for your robot to be. How would it move through the water? Does it have like a propeller, or how are you planning to navigate through the water, especially if it needs to make turns or back up?
It has a propeller in the front to make it motor.
No, in the back.
In the back, make it
Move.
move. And the pipes.
Yeah, that's great. I think back is it's good to take cues from kind of the real world and what else works out there. I think a lot of times you see airplanes, you see propellers on the front, but if you look at like submarines, they're usually on the back, right? And I'm definitely not an expert, but I'm sure there's probably a pretty good reason for that. So I think as you're thinking about prototypes, looking at those things would be good. I'm curious, what was in your video with the robot? What was the red card? It was kind of hard to tell. What was the red card?
So it could turn left or right.
I was telling it to turn.
It's telling it to turn left, because if it sees something in its way with the distance camera right here, then it'll turn right. But if it sees red on the smaller camera right here, then it'll turn left.
I see. Okay. So two last questions. First one is, what was the hardest part of the project for you and the prototypes that you built?
I think the hardest part would be coding it, like they said. So I think it would be coding it and building it, because like for a little bit it was unbalanced and unstable. That's why we had to move the arm to the back. So in the drawing, it's not fully accurate to the actual thing. And then we added a tank, and then we put, we had those back wheels on the front, but then we put them back to balance it out.
That's great. So it sounds like you went through a couple different iterations on your robot there. And what do you think what do you think the next step, what would be hard about your next steps, building your waterproof version?
I think what would be hard about it is like getting the material to the water.
Okay.
Did you show this prototype to the Durham County point of contact?
He saw the video that we did.
Video? Okay. What was his reaction?
Pretty cool. He said it was pretty cool.
Nice, nice. Okay. Um,
When you
did
showed
you?
it to him, did you ask? Oh, I'm so sorry. I wanted to
Sure.
just build
No,
off
no,
that.
go ahead.
When
Go
you
ahead.
showed it to
Go ahead, Michael.
when you showed it to him, did you ask for any feedback of like, would this work out well, or does this kind of address the problems you saw? Did he like have any other than like, oh, that's really cool? Do you have any feedback about like parts that were good or maybe parts that could improve?
We could extend the camera, like make the camera sensor like a little bigger.
And one thing he said, so one of our first designs before we changed it to a submarine was that if we were planning to do something kind of like theirs, but they already had something kind of like that, so we changed it to a submarine.
Yeah, it looks like both the robots can sort of work in tandem and fix the larger issue. I don't think there is. I mean, the problem is the same, but you both approached it in a very different way. I think it's really good. They both can work together. You're right. What else? Did you? I think you spoke about it. Did you? What were the major failures in the prototype that you did early on when you approached this problem?
Yeah, that was balance.
Sorry?
Balance. It was balance.
Oh, balance. Okay. Oh, wow. Okay. Yeah. What did you do about it? How did you make sure it was well balanced?
We added weights to the back, and instead of taking stuff
I
off,
see.
we only took the arm off. We moved it to the back. So like, like this part, it was on the front. It was like that. It was like
Got
a
it.
claw.
Yeah.
It was like a
Mhm.
arm. So like we moved the thing to the back, and then instead of taking the front wheels off, we put them to the back. And like
Yeah.
and to like balance it out more, we added more weight to the back by adding the tank.
Nice. That's really innovative. So you have to do that again once you put it on water, right? Again, you'll have to look at balancing it out. Is that right?
Yeah.
Once
Yes.
yeah. All right. How do you plan to do that? How do you plan to do that once it starts floating on water? How do you make sure that it doesn't sink or tilt over?
Material.
Yeah, maybe add some counterbalance. Add a sail to it.
Sail.
All right. Thank
Or
you.
sometimes just trial and error, right, team? Yeah.
Yeah.
Last question for me, because I could probably use it. What do you know what the sealant would be? Like, what would those robots spray out to seal the pipes? Because I've had leaky pipes. It's a problem.
Flex
in the
Seal.
past, I mean. Flex Seal. Okay. You thought it through. That's great. Thanks, team.
Amazing job, Team Leak Hunters. And thank you so much, Zebulon Middle School. Let's give them all again a warm round of applause, hearts, rockets. We love it all. Congrats, everyone, for an amazing job. Well done. All right, everyone. So we are going to move on to our last school, Paul Revere Middle School. All right, Paul Revere Middle School. Students, are we ready? If you're ready, please give me a thumbs up.
Yeah, we're ready.
Amazing. All right, so we are going to start with the first team, which is Team the All-in-One team.
The all-in-one team. Clockwise. Andrew, Safat, Maxon. Meet our community partner, Miss Preciado. Miss Preciado is a 7th grade counselor at Power Revere Middle School, and she is dedicated to helping our team building the ultimate energy-efficient device.
The problem we're trying to solve lies in the fact that communities waste so much energy every day, especially homes, businesses, and schools. The all-in-one basically combats climate change with its features. Our microbit all-in-one fixes all of these energy shortcomings by utilizing the power of 2 separately coded Microsoft microbits. The yellow one is for temperature detection, whereas the red one is for brightness detection. The owner of the device can adjust their lighting and thermostat accordingly to save vast amounts of energy over time.
And here's the video.
One of the most incredible energy-efficient devices. This device consists of 2 major microbits, the temperature and the light. Both of these microbits are color-coded. This one, like I said, measures the temperature and it displays a number depending on the level. And the same with this, but this is just the light. Now this device, that 100% helps save energy, mainly targeted for schools, companies, or corporations.
Here it says the light levels are 30. No, now it's 0 since we're indoors. And it says it's 70 degrees Fahrenheit. So let's go outside and see what happens. They all exhibit a different sound depending on fluctuations in... See? Due to the temperature and light fluctuations, both of them are going off.
The inputs each respective microbit receives are temperature and light levels nearby. The data recorded is flashed on the microbit LEDs that the device's owner sees.
Our first microbit included the essential technology involving these microbits, alongside some conveniences for the owner, like a carry handle. It was really bulky.
For our second iteration, we simply flipped the previous prototype up and added Velcro for being mounted on the walls. This was to make it more easily placeable around the building. This was also to make it mountable and to make it smaller, according to Ms. Preciado. Our third iteration improved even more on what Ms. Preciado said about our earlier iterations. We did so by considerably reducing size. People can easily navigate the device. The battery compartment is easily accessible as well. Here is a graph showcasing the U.S. energy consumption and some of our key competitors.
Next steps. Our device is still very primitive, but we plan to make lots of changes to help more and more people. Thank you for listening to our presentation.
Amazing job, team.
Well done.
The team all in one. All right. Judges, let's get started on the questions for our students.
Michael, you want to go in?
Sure. Yeah, great job, team. I'm curious, and I apologize if I missed it. Is it because each microbit had a sensor? Were you able to look at maybe having one microbit that could do it all as even a next phase of an all-in-one, or was there a major constraint of why you had 2 microbits? I think that was a good solution, but I was just kind of curious as to the why.
Well, the 2 microbits are mainly for 2 key components, which are all used to save the most amount of energy in large buildings like corporations and the places you are right now. And one microbit is mainly used for measuring how much energy is used, and then the light levels and just all that stuff to like indicate when to turn stuff off and when to save stuff, and like stopping energy from being used when it's unnecessary. And yes, in the future we can make it into one major, just like one microbit that can detect everything, and it will be more advanced.
Is that because are there sensors built into the microbit, and is that what you're using to measure the light and the temperature?
Yes. Yeah.
Okay, that makes sense. Yeah, I've seen it sometimes where you can plug in a sensor into your board, and then you could have multiple sensors running off of one board. But now I understand. That makes a lot of sense.
Yeah, it's basically an energy saving manager that does not use any AI. It's all coding.
That's great. What happens when it does detect energy usage? Does it alert someone, or how can it differentiate between the lights are on when they shouldn't be, and maybe the lights are on when people are using the room?
There are different sound cues.
Yes, and it is on a timer, and it also detects when people are using the lights and not using, and it also affects the AC and other numerous parts that you use in your everyday homes or offices.
Awesome.
How did you source these microbits? Where did you get it from?
We coded it online.
Right. I mean, the physical, the sensors,
We
were
also
they
bought
part
those
of? You want those online? Okay.
Yeah.
I saw that in the demo, the microbit sort of gives a sound out when there is a change in temperature. What does that mean to a person who is using?
It means that was our first iteration when it didn't have the managing ability, so it cues when specific lights should be turned off and conditioning when it is using excessive amounts of energy.
Right. And how does it detect? So one was a light sensor, the other one was a temperature sensor, right?
Yes.
If I'm not wrong, right? So if let me give you one practical situation, right? So I'm sitting in a room with the AC on, right? And it matches the exact temperature that is outside. Assume that you have something, or maybe it is cooling down. How do you know that I'm using more energy or I'm using lesser energy?
Well, the temperature sensor also intertwines with the lighting sensor, which is it sends a specific sound when excessive amounts of energy, and how it does this is here. Let me show you.
Yeah, go ahead.
So this is our 3D printed version.
Oh wow,
And
it
basically,
looks super cool.
yeah, so basically what it does once it's connected to the wall, you can also like intertwine it with your AC, so it can track how much you're using, and it can like see your patterns of when you use it and like when you turn it on. So that's how it knows when you're like using it, and it matches the outside temperature.
Can you hold it up a little bit? I couldn't see the whole 3D prototype.
There's also
Nice. Is that the battery inside?
Yeah.
Yes.
Okay, nice. Yeah, that looks so small compared to the prototype that you did with a cardboard box.
Yeah,
That's
this
really
is the
good.
smaller.
What is this?
This is our second iteration. We just took all the
Oh,
micro.
okay. I see. Okay, got it. Okay, thank you.
That's
Nice.
great, team. It's really cool to see the evolution as it's changed with each iteration. I like too that you said that it can track usage, so maybe it can also. It sounds like then you could use that to see if like habits change, right? And maybe that's one way you can also tell, like, okay, normally these are the usage times, and then if it's still detecting usage outside of those times, it can send the alerts. Is that right?
Yep.
Yeah, that's right.
Okay. One thing I would think about is is it only sending an alert when it's detecting extra usage or wastage? So I guess my question is kind of, how do I know what's a bad sound versus maybe just another noise it's making, unless it only makes noise when it needs attention because it's the extra usage?
The iteration we have now only makes one noise, which means to like turn off that specific thing. In our future iterations, we can like have it hooked up to computers so you can access even more.
Yeah, on your personal device. Yeah.
That's great. What so you've done a couple different iterations, which kudos to you. That's really awesome, you guys. What would, if you're going to take the next step, because you probably already have ideas of like how to continue to make it better, what would be your next steps, and what do you think the big challenges would be?
Maybe we can upgrade the microbit. This is more of the basic version, but there's a more advanced one available online. So if we upgrade the microbit, maybe we could have one microbit, as mentioned earlier.
And definitely like using other like computers, phones to like have major access like into more like larger buildings like schools and like large office buildings to manage it all.
Yeah. And maybe install it remotely and have a Wi-Fi installed on it.
Yeah.
Right? And yeah, I mean, you could take it so many ways. You have built the foundational part of it, right? I don't know, I can think of having a memory chip inside so that it can have some sort of a memory, as Michael said, right? You can have it can track your usage over time and alert you, and those are very nice things. Sorry, go ahead.
We were thinking of a third component. Like we have light level, right? And the temperature.
Right.
Maybe there can be a third component, like as you said, a memory chip or to track the data usage. I mean the energy usage.
Right.
Third component. Maybe even 4.
Yeah, about the challenge, maybe it would be a really big challenge to reprogram everything for the one microbit, but we're ready to face those.
Yeah.
So
Awesome.
Well, great job, team. Really enjoyed it.
Yeah, very good job. Thank you.
Thank you so much for your
Thank you so
time and
much.
letting us like show you our invention. We worked really hard. Thank you so much. This has been a really
Absolutely.
great
Thank you so
experience
much.
for us. Thank you.
Awesome job.
Thank you.
Thank you
Thank
so
you so
much,
much.
team, all in one. All right.
Thank you.
All right,
Thank you so
team.
much.
Of course. Great job. Great job. All right, everybody. So now we are going to move on to our second team from Paul Revere Middle School, Team Light Saving Movement.
Our product is the Light Saving Movement by Hannah Nazarian, Dashiell Brecker, and Christian Kenner. Now, meet our team. First is Dashiell Brecker, our competitor finder, slide writer, and he brings the team together. Next is me, Hannah Nazarian, our liaison and slide and product designer. Next is Christian Kenner, our coder. He found the problem and solution to our product, and he built the product. We partnered with 7th grade counselor Miss Preciado at Paul Revere Middle School, who stated that the light usage in our school is a big energy expense. Because of that, we designed a product that reminds people to turn off the lights. It's approved by Miss Preciado, and she's excited to actually use it in school.
Every day, a lot of energy gets wasted because people leave lights on when they are not needed. This may seem like a small problem, but over time, they can waste a lot of energy and increase the cost of the energy bills. In places like homes, classrooms, and offices, lights are often left on by accident when people leave the room. This is why lighting is one of the main causes of wasted energy. Because of this, we wanted to focus on creating a solution that is simple, effective, and easy for people to use. Our solution is a light sensor that can detect when the brightness in the room goes above 100 they are not needed. Once it reaches that level, the device will beep as a reminder to turn off the lights. This helps people remember something they might forget. In places like home, in their daily routine, they can use this. By giving a quick alert, it helps save energy and lower electricity costs. We believe this product is innovative because it uses technology in a smart way to solve a common everyday problem that is simple, effective, and easy for people to use.
That's our microbit. It's basically the only electrical component of our product. And then if you go inside here, that's our power bank down there with the red wire. It charges the microbit, and then this is the base of the product. But we're gonna upgrade it and make it more sleeker and modern once we get our 3D product.
Our product features our microbit BBC V2 programming chip,
automated light sensor and a light detector that makes a noise when the energy in the room starts to get wasted. The microbit helps programming our product. The light sensor benefits people who would like to save energy by cutting down on their light usage. Lastly, the detector helps the person who uses the product. When we tested our first prototype, Ms. Preciado gave us really positive feedback. She said she liked the idea and would actually use it. Her main suggestion was to make the design more sleek, modern, and smaller, so it could be easier to place in her room. Her feedback was very helpful because it showed us that our product had value and it gave us confidence. Also, it gave us a lot more ideas on how we can improve our product even more.
Our product is different from other big companies because of our diversity. Our top 3 biggest competitors are STM Microelectronics, NV Murata Manufacturing Co., LTD, and Robert Bosch GmbH. All of these companies specialize in one thing. Some are very good with technology, and others are good with their reliability of good quality and how their product works. However, our product is a mix of good technology and really good making. That's why you should choose our product. First of all, we want to ask Ms. Preciado what we can do to benefit our product and have the best chance of succeeding. And then we would also like to get as big as these companies because we're trying to overtake them in sales and marketing. And then overall, our technology will also get better over time. And then we are looking forward to rework our products to make better versions like a V2 or a V3. And with that, we will be able to overtake the other competitors and we will be better than everyone and we will succeed.
Awesome job, Team Light Saving Movement. Let's give them all a warm round of applause. All right, judges, the mic is yours.
Great job, team.
Right.
Great presentation.
Yeah, congratulations. Yes.
Thank you.
This
Thank
is really
you.
good. Where is your chief presentation creator? You're missing a team member.
Oh, yeah.
Yeah.
She's in Palm Springs right now.
Oh, wow. Okay. She's testing the prototype.
Yeah.
Nice. Right.
Um,
Go ahead, Michael.
I had a question about your prototype. So one of on your demo, the walkthrough was really helpful, and then on the next slide, one of you was talking about the components. As you said, there's a microbit, right, and the power bank. There's a light sensor, and there's a detector. What's the detector? I think I missed what that does or the function.
So basically, when the lumen levels of a room exceed 180, it's gonna make a noise to remind you to like turn off the lights because you're wasting energy, and that's like what the detector is. So it detects the lumen levels inside the room.
Oh, I see. So it works with the sensor.
Yeah,
Yeah.
it's inside the microbit. How I coded it, I made it there.
I got it. So the light sensor measures the lumens.
Yes.
And the detector is doing the logic of it's exceeding the lumens, send the alert.
Yeah.
Yeah.
Okay.
Exactly.
Oh, that's great. Thank you. What how would the detector or how would your product be able to differentiate or know the difference between somebody using the room like normal because they're teaching a class or something like that versus when the room's just empty and we're wasting the light because no one is using it?
So Miss Preciado has multiple lights in her room. So when she was using it, when the lumen levels were 180, it made the beep. So she turned off one of her lights in the room, and then it stopped making beeps. So then she could use the room.
So make sure that you're not using more light than you ever
Yeah.
do whenever.
Yeah.
Okay. Yeah, that makes sense. And how did you come up with that light level? Why you said 800 lumens? Why 800?
180.
Yeah, we looked it up, and that's like what all the other competitors have, and we just like noticed like that's like basically like the average of like light usage or like below average. So we want to get below average of the light usage that people use.
Got it.
Yeah. We also had to pivot multiple times from our inventions. So this was like our last invention that we were gonna make.
Yeah.
Because at first we were gonna do a light switch
that automatically turns the lights on and off when you want it to. But then the coding for that didn't work, so we pivoted from that to this. And then we struggled with this when we were doing the coding, it was like really hard. And then when we did the coding, we were like, oh yeah, this is gonna work. This is gonna get us, yeah.
Well, kudos to you. I know how hard it can be when pivoting, especially if you've been working on something for a while. I think that takes a certain amount of bravery, so that's pretty awesome. Props to you guys for making that decision and running with it. And you got something that's worked, so it's great.
Yeah, thank you.
I am curious about your competitor matrix because you spent a bit of time talking about them. So you outlined a couple of companies.
Yes.
What are their actual products that you would be competing with?
So the product from one of those companies, they make these they're like these tiny sensors, and that you put them on like a wall or on the table, and they basically scan the room. When there's people in it, you have to like say that there's someone it's being used, and then when there's not, you turn that off, and then it like detects the light. So then it makes the thing. Yeah.
Did you also try doing the detection, the movement detection?
Yeah, we tried it and it works.
Yeah, it works.
Okay, so it's only when people are in the room you detect the lumens, and if there's nobody else, then it can automatically switch off. Is that what your
Yeah,
product
Yeah,
also?
there needs to be someone who can
Oh,
like turn
awesome.
off the lights.
Oh, okay. I didn't see that in the demo, but good. Yeah, I didn't know that.
Yeah.
But awesome.
Yeah.
Perfect. What do you intend to do in V2 and V3? Sorry, Michael.
So, speaking of the thing where you said about the room, so in the V2 and the V3, we're trying to add another sensor that detects the people who are in the room, because as you said, we don't have that amplified yet. So it's like kind of difficult for people to use it well enough even if they're in the room. So it might be like annoying, like just to say I'm trying to use the room and the thing just starts beeping. So we're trying to add a sensor that detects if there's someone in the room and the room's being used, but if no one's in the room, then it would work.
Right.
Gotcha. And I think in your video you mentioned you had the cardboard box where you're waiting on a 3D print. Did you all get
Yeah.
that point?
We did get the 3D print.
Yeah, we did, but it just like it didn't print like fast enough. Yeah.
Do you have it with you? Did you eventually get it?
We don't have it with
We don't
us.
have it with us.
That's okay. It's all part of the process.
Yeah.
During when you're building this, you mentioned, I think, looking at your competitors. Was there any other research you guys did?
Yeah, we were looking at their price range, and they're basically they're from $60 to $100, and ours is going to be $55.
Okay. How did you arrive at that 55?
So at first we were also gonna do $60, but then we were thinking like, why would we do the same price as our competitors if you want to be better than them? So we just
Right.
went in the
So to be better, it might cost you more, right?
Yeah, that's true.
How much does it cost you to make the product?
Like $30, $45.
Something like that. It ranges between like 30 and 45.
Wow. Okay. Yeah, that's a good margin.
Yeah.
All right. Go ahead.
Did you all? I'm curious. So when you did your research and you set the alert at 180 lumens,
Yes.
did you do any kind of calculation of like, or measure like what the rooms are currently at? Because one way, if you're looking
We
at
did.
selling the
We
product,
did.
like
We did measure it when we were testing it. We made the lumen levels to not beep, so it could just go as high as it wants to. So when the lights were on in when all three of the lights were on in Miss Preciado's room, it was at 250. So that's 70 more than what we want. So she was wasting a lot of energy.
Yeah, for sure. So that would be cool to like be able also to show like how much energy and maybe how much savings. You
Yeah.
get from this product, right? Very cool.
Thank you. Thank
Yeah.
you.
Thanks, team.
Thank you. Yeah.
Thank you
Well
so
done.
much. Thank you so much, Team Light Saving Movement. Awesome job, everyone. All right, so now we are going to move to our third team from Paul Revere Middle School, Team Solar Booster. So this will be presented by Ariel, Sincere, Misty, and Shayla.
The Solar Booster, a solar-powered solution for charging school iPads by Ariel, Sincere, Misty, and Shayla.
Overview about our slides. Our team, about project event, the problem and community partner, solution, demo and blueprint, product features, user testing, competitors, next step, and thank you for listening. Hi, my name is Sincere, and my favorite thing to do to help the community is recycle. And I'm the prototype tester and also the project designer.
Hi, I'm Ariel. My favorite thing to do to help the community is picking up trash, and I'm the presentation designer.
Hi, I'm Shayla, and my favorite thing to do for my community is to beautify it. In the project, I am also the presentation designer and the microbit coder.
Hi, I'm Misty. My favorite thing to do for my community is doing wall murals, and the project I created the first prototype and designed it.
About Project Invent, the program. Project Invent is a program where students create inventions to solve real-world problems. Students work in teams to design inventions that help people in their communities. Project Invent helps students think creatively and solve real problems in their community. It teaches teamwork, problem-solving, and how to design useful inventions. Students work together to come up with ideas, build prototypes, and test their solution to make positive impacts on others.
The problem and community partner. Our problem is that many iPads lose battery quickly, sometimes overheat, and take a long time to charge. This makes it harder for students to use them during the school day. Our community partner, Ms. Preciado, is a counselor at our school who shared ideas about saving energy and improving student resources. Her ideas helped us guide into creating our own solution. And on the right, we have Ms. Preciado.
Solution. Our solution is a solar-powered charging iPad. An iPad that uses solar energy to charge iPads at school without needing a wall outlet. It includes a built-in stand to hold the iPad and a microbit that helps prevent overheating by alerting when the device gets too hot or when it's fully charged. This makes charging safer, easier, and more convenient for students at our school.
Demo and blueprint. The blueprint you see besides the test is the first on its own charging LUC iPad that is made from cardboard and microbit. As you could see, also our friend Shayla made the blueprint, and we'll talk more about the product features on the next slide. Product features. The Solar Booster iPad has a built-in solar-powered panel that comes with a case to hold the iPad securely, shields the iPad from overcharging, and this device also uses microbit to prevent overheating by monitoring temperature. It is portable, easy to use, and works with all iPads, making it convenient for students at school. Hi guys, my name is Sincere, and I'm going to be showing you guys the Solar Booster iPad that our friend made, which is Misty. She's a really great designer, and she is a project designer. Here we have is the inside, which we have is our iPad. We are going to be designing the app soon. And then here we have on the back of the iPad, which is the solar panel, because it's a solar charging iPad. Because the sun, when you turn it around and you open it up, you can see the solar panel, which also reflects to the sun, which makes it charge, which is really cool. And here we have our stand works really well, as you can see. Here we have is our battery right here, a lovely battery. And then once you turn the battery on, you can see the temperature, or if it's overheating or not. Since it's beating, that means it's overheating right now because it's really hot outside today. And that is our solar booster. Bye guys.
Competitors. This is a Winky P2HPK pink solar iPad case for iPads 1 and 2 with HDMI. These are its problems. Number 1, it's $150. Number 2, its a global rating is 3 stars. Number 3, the iPad case is made for only iPads 1 and 2. Benefits of our iPad case. It's $44.99. Number 2, its iPad case will be suitable for all iPads. Number 3, the iPad case will be sturdy and won't break when dropped.
Next steps. Our next steps are to create an actual product with superior technological materials instead of using cardboard. We would want to have companies approve us, buy from us, and hopefully have our product in stores.
Thank you for listening.
Awesome job, Team Solar Boosters. Lovely. Thank you so much. All right, I'm going to give the floor to the judges to start the questions.
Great job, team. Hi.
Hi.
Really good presentation. I think you all were very thorough. I think you did a really good job of explaining your process. So props to you for that. I also really loved that you all explained your favorite thing to do for your community. And I think those are all incredible, like cleaning up trash and litter and beautifying and wall murals. That's pretty awesome. So I really enjoyed all that.
Thank you.
Thank you.
Thank you.
For your demo video, it seemed like I had a little hard time hearing it because it sounded like there was a second video playing. Apologies. I know. Frustrating.
Yeah, I'm sorry. It was supposed to play one at a time, but it played together, and we fixed that on our iPad, but we didn't know that you guys were controlling it. So that was our bad. Sorry, guys.
Oh, sorry, team. Yeah, I know what that's like to like fix it at the last minute and then it doesn't.
Yeah.
But I think I understood it. I just want to clarify. So I think your main invention is the case for the iPad, right? And so that's got the impact resistance and helps protect it. And then the back opens up, and then that's where you have the solar power channel. So if you don't want to charge it, you would turn it over, open up the back so that it's doing that. And then it also has the temperature sensor incorporated to make sure it doesn't overheat. Do I have that right?
Yeah, that's exactly it. That's exactly it.
Okay, very cool.
Did you Merit, how did you come up with this idea?
Actually, our friend Misty, she's not here today. Well, she's not here right now, but she came up with it, and then we're like, that's a really great idea, because like that's something that all students face at our school. So like we could like make a solution for that problem.
Yeah.
Nice. How many iPads do you have? How did you find out how big the problem is?
Well, because our classroom is basically an energy saving class. We did multiple projects, and a lot of our projects were about energy saving. So I guess when we made this project, we thought about adding to energy to the iPad to the point where we made a built-in solar panel to it. And we also made a 3D printed version that's not with us, but it is smaller than the actual version here. And we felt like bringing this one because it has more detail to it.
Yeah.
Nice. Yeah. This is really awesome, I think. Yeah, this solves a really big problem for all the schools. You can even look at it as not just iPads. You can probably charge other devices too, maybe phones and laptops and anything else. Right?
Yes.
What do you what do you intend to do with maybe next version?
Wait, say what?
What do you intend to do for the next version of it? The next iteration?
We want to make the case an actual real thing, like make it an actual product, and we want to actually test it on an actual iPad, because for this we didn't use an actual iPad. It's just cardboard.
Yeah.
So we want to use like an actual iPad.
Is it the way it works in your school is every student issued an iPad?
Yes.
Yeah. So just thinking about the energy savings. So if you have a whole school, so probably hundreds of iPads, right? And they're all currently
Yes.
plugged into the wall.
Mhm.
If you had one of your cases for each of them, did you all try to do any of the math to calculate maybe how much energy you'd save if the iPads could be charged every day with a solar energy?
No, that's actually not what we came across, but that's also a part of how we're going to make our project better. So that's probably what we're going to do to make our project better.
So kind of do that calculation is kind of a next step?
Yeah.
Okay.
What problems did you face when you came up with this prototype?
What problem did we face?
One problem that we faced was like trying to connect, like if we were to use like the microbit on an actual iPad, then we tried to like connect the microbit the microbit and the battery like this, and then like to like make it connect and like tell the temperature of the iPad when it overheats, but like we couldn't do that because it wasn't like we didn't we couldn't really figure out how to connect it to a real iPad. So that's why we use a cardboard one.
Got it. So the microbit also uses energy, right?
You said what?
The microbit that you have, that also uses some energy. You have a battery powered microbit,
Yeah, we have a battery pack that we hooked up to it because we can
right?
show you. Yeah, we have a battery pack to it that show like you can see it if you want to, but it's a battery pack, so you don't have to plug it in. And you're not supposed to it's not gonna turn on multiple times, but like if you keep it in the sun, it will tell you when it overheats. It will start showing the numbers of like how hot and how cold it is. But yeah, that's really it. But we're gonna also do the little math that you guys said that you guys gave us to do, but we're gonna do math to it.
Yeah. In that math, you might also want to consider the power the microbit takes, right? That's an extra power that you didn't have all these days, and now you are using extra power. That was extra energy that it takes just to detect. So you are on one hand, you are charging all the iPads with solar energy. On the other hand, you have a microbit which uses the battery, which also is consuming the energy. So you will have to figure out how to save on both sides. Correct?
So basically, you want us to try to make it without the battery pack?
Of course, yeah, that's a good idea. How do you do that if you were to do it? How do you want to approach it?
Well, I don't really know. I would think of it as like, I don't know how I can do that, but we'll figure it out. Maybe we'll probably not use a microbit. Maybe we'll use something different, like a different type of panel that actually takes its own energy from itself and it doesn't need anything we need to add on, and we can just connect it. But yeah, we're probably just not going to use the batteries anymore. So it saves more energy for our classroom and other people around us.
Or use the solar panels that you already have there. Right.
Yeah, exactly. If your solar panels are charging the iPad, maybe think through, is there a way where you could have it charge both, right? So maybe the battery pack you have, maybe a different battery pack that can be recharged, and then use the solar panels to charge both. Might be a solution.
That's a good idea.
Like a solar panel connected to the microbit that charges it up?
Yeah, and it could probably be the same solar panel, and you could figure out a way you could have it split and connect to both, right? Cool.
One last question. Where do you live? Just curious. What part of US is?
They're in Los Angeles, right?
Los Angeles? Okay. Oh, that's a good idea to use solar panels. I was planning to ask, what do you do in winter?
What do we do? What
Will solar panels work same way
will?
in winter
Oh,
too
what do
when
we do
it's
in
cloudy?
Oh, you're saying what do we do in winter?
Mm-hmm.
I don't think we know.
I don't think we know
We
because
haven't figured that
out yet. Probably because it's
Okay.
very hot right now. It's really
Right.
hot when we started to make the project, so we never really thought of it as like cold because we didn't really look onto that. We didn't look onto the future of we didn't look onto the future what we're gonna do with our project.
Yeah.
You
Something to think
you'd
about
probably
for
be
V2
okay.
and V3. Yeah, but it's a good demand. Yeah.
Mm-hmm.
Right.
I'm an Indiana team, so I think as you think about your product, in places like California would be a good market where you could sell it. But I'm in Indiana, and in
Okay.
Indiana in the winter, it's overcast cloudy every single day. Kind of like
Yeah.
I just learned you all have something called May gray and June gloom. So maybe like the mornings it's overcast. Where I am in the Midwest, every single day, all day, it's overcast. So there's not a lot of sun energy. And so it might be harder for us to use that product during the winter months. But I think for you all, it probably wouldn't be as big of an issue. Cool. Well, great job, team. Really enjoyed it. Great.
Yep.
Thank you.
Thank you.
Well done.
Thank you so much, Team Solar Boosters. Amazing job. All right, team. So now we are going to move on to our last and final team from Paul Revere Middle School, Team Temper Shirt, presented by Asher, Jaden, and Liam.
For sure. By Asher,
Jaden, and Liam.
Garfield Moore is our community partner. He has trouble falling asleep because it's too cold. It takes Garfield 30 minutes each night to fall asleep. Garfield often wakes up in the middle of the night having a runny nose, and it's hard for him to fall back asleep.
It's hard to fall asleep when you can't control how hot or cold you are. For some people, their surroundings need to be perfect so they could fall asleep. Being too hot or cold while sleeping can disrupt your body's natural temperature, preventing your body to balance itself, forcing your body to waste energy trying to regulate itself through shivering or sweating. The temperature works by having 6 Velcro straps on the shirt and 6 Velcro straps on the heating and cooling pad, so you could easily attach the pad onto the shirt. To heat the heating pad up, you put it in the microwave for a couple of seconds, and you could repeat that until you like the heat. When you want to cool the pad down, you put it in the freezer for a couple of hours until the pad gets cold. How you assemble a shirt. You put the shirt down flat, and then you put the microbit, which tells how hot or cold the surrounding air is in Celsius and Fahrenheit. After you put the microbit down, you put the pad on the shirt, and it attaches by the Velcro straps. For our first prototype, we went to Thinkercad and got all the supplies we use to make the temper shirt. We have a shirt with 6 Velcro straps on it and a heating and cooling pad with 6 Velcro straps on it too. And we have a microbit. That all came out to $38.99. It shows how we assemble the shirt after you heat or cool the pad. First, you lay down the shirt neatly, and then you put the microbit. After you put the microbit, you put the heating or cooling pad on top of the microbit, which attaches onto the shirt by the Velcro strips.
the fan is on our microbit, which goes under the heating cords and battery. The heating cords gets charged from the battery. The total cost for our product is $60, and the sale cost is $80. The temper shirt has thin wires in the shirt that connects to a power source. This heats up the shirt. The power source for the thin wires is a lithium-ion rechargeable battery that helps heat up the shirt. The microbit is attached to 2 fans that cool down the shirt. On the microbit, there is a knob that you can turn adjusting the speed of the fan, making your shirt get to the correct temperature for you. The thin wires will take a few minutes to heat up. We did this because our first prototype could only heat up through a microwave and cool down through our freezer. Our second prototype doesn't need a microwave or a freezer. First competitor is the Action Heat 5V shirt. This shirt can only heat up and can't cool down. The shirt is currently for sale at $99.99, but normally sells for $159.99. Our second competitor is the OctoCool. The OctoCool is an air conditioner shirt that has fans in it. The shirt can cool down but can't heat up. The shirt ranges from prices of $60 to $90.
Questions we asked Garfield. What do you think of the second prototype? I think the prototype is great. I love how the fan cools down the shirt and the heating system. This could really make a big difference for my sleeping. What do you think of the second prototype compared to the first one? I think the second prototype is better because it's more user-friendly and I don't have to put it in the microwave or in the freezer.
Thank you for listening.
Awesome job,
Very
Team
well done.
Shirts. All right, Mike, Prasanna, take it away.
All right, congratulations. This is really good. I see that you have a prototype. Do you want to show it? Like on the keyboard?
The first one is a shirt with a pad, but the second one we haven't made, but we made a design model on Tinkercad.
Oh yeah, let's go ahead and see what it does. Do you want to show the demo of it?
Yeah. So we made the microbit. We coded it so when you turn the knob, it turns the fan on, and that's how for the second prototype you get cooled down. We haven't done the heating part.
We have it.
Oh yeah, we did the cords, but we don't have it live.
Right.
We only have the fans.
Okay.
Mhm.
Very cool, team. I loved seeing your first version, your prototype 1, and how you kind of identified some of the challenges of like being kind of cumbersome to put it in the freezer or the microwave to cool it or heat it. So I love how you took that feedback and moved into the next phase. And also, good job in your presentation. I appreciated how you got feedback from Garfield, from your user, and then use that to kind of like inform your next version. In your next version, if you're like continuing to do the next step, how would your user control it? Either how would the cooling system turn on, or how would the heating system turn on, and how could you like dial in settings?
Well, for the cooling system, you can turn the knob for the fan, and then the heating system, you use the cords, which you turn on with a remote.
Gotcha. So you'd have a dial somewhere on the shirt to turn on
Yeah.
and control the fans. Okay.
Yeah, it's also waterproof, so.
And how will the fans, can you talk a little bit about, or have you thought through how the fans will be incorporated into the shirt? Like, I'm just curious, like, so looking at that, like, is the fan going to be smacking against somebody's body, right? Or does it have enough movement around it so that it can move freely? How would you incorporate the fan into the shirt?
So there's like these type of like box fans that like won't hit you.
Okay.
So we were thinking of putting it either for the shirt, so like it just keeps going when you're like, so you won't get hit. So it just hits there and then just like you just get the air. That's all.
It's like built in the shirt.
Yeah.
So it has like a little box or an enclosure to
Yeah.
keep the user protected from the blades, and to make sure the shirt doesn't get like dusted up, right?
Yeah. It would be the fans that they use in a 3D printer to cool the nozzle down.
Yeah. Okay. Yeah, that's a good solution. Those, you can find those fans pretty readily available. It's the same type of fan they use to cool down PCs, right? Or if you have like a gaming PC,
Yeah.
it'd be the same type of fan.
Yeah.
Do you think it will be comfortable sleeping with the fans on?
No, the fans it wouldn't bother you. Like it's built in the shirt, so you'd still feel the
Hmm.
shirt. You wouldn't yeah, you wouldn't feel the fans when you're sleeping.
What about the noise?
You mean with the cords?
No, with the fan, with the blades. Is does it does it have a
There's
lot of
like
noise? Does it produce a lot of noise?
Oh, the noise.
no,
Yeah,
it doesn't. There's like something separating it so you wouldn't like get hurt or anything. So that's why
hmm,
it's already like built in like for those type of fans.
Oh
I
yeah,
see.
all you feel is the shirt. You wouldn't feel the fan on your body. Like you'd feel like the air coming through it, but you wouldn't feel it like against you.
I see. Okay.
So is the idea that it would pull air in and put it onto your body, or would it pull air off of your body and pull the heat away? Do you know what I mean? Like which
It
way
would
is the fan blowing, moving air? Is it moving
it would
towards me?
it would pull air into your body.
Into. Okay. Yeah, maybe think about it. Yeah, that could work. Or think about how it works on the 3D printer and check like is on your 3D printer, is it pulling air onto it or is it pushing hot air away? And I think you might be surprised how they've used it. Maybe think about that of how it informs your design. And I think to Prasani's point, those fans can be noisy, right? So maybe you might want to check with your user of like, are they the type of sleeper that needs like absolute quiet to sleep? Or if they're the type of sleeper that likes white noise, that might actually be a product feature, right? Of having that
Yeah.
noise of the fan go.
Yeah, and Liam actually he's slept with it on him before.
Really?
He's actually slept with the shirt. We've tried it and he slept with the shirt on him.
Which one, the prototype 1 or prototype 2?
Prototype 1.
Okay. How was it sleeping with it?
Oh, he actually slept.
Oh, Jaden, sorry.
It was nice. I had nothing wrong with it. The Velcro didn't affect me or anything. It was like easy to sleep with, and it felt nicer for my temperature. So I didn't even need to like use a blanket because I had that shirt on, so I was just fine the entire time.
Okay.
Are you planning to build? I mean, t-shirt is fine. Are you planning to build anything else like a cap, air-conditioned cap, or something like that?
Yeah. We were planning to build like a case for the microbit that would
Mm-hmm.
kind of like it wouldn't be like on the shirt, but it'd be like around the shirt. So you wouldn't, it'd be like near the shirt. It'd be like remote controlled.
Right. What I was asking is, are you planning to build any other garments apart from the shirt, like a hat or a cap?
We didn't really think about that yet. We have
Okay.
only thought about making the shirt right now.
All right. Makes sense. It might be really useful if I were to go outside and when it's sunny and I'm wearing a cap which is already temperature controlled, I can
Well,
really feel
It's more, yeah, but it's more of a sleep shirt.
sleep shirt. Okay.
yeah,
Makes sense.
we chose to do a shirt because Garfield, when we interviewed him, he said
Right.
that he has trouble sleeping because of he's either too hot or too cold. So
Right.
that's the main reason we made the shirt.
Makes sense.
Yeah. That does make sense. For Garfield, it's interesting it's too hot or too cold. And so I noticed you said for your competitors that their shirts could either do hot or do cold, and that's why you wanted to do both.
Yeah.
Does that change like per night for him, or does that change throughout the night? Would it need to be hot at one part of the night and then cold at another?
Well, it could work that way. The shirt could work that way, but normally, he struggles with it being too hot one night or too cold the other.
Or throughout the year when
Yeah.
it goes from
throughout the year when it goes from summer to like winter.
Yeah. Yeah, that makes sense. Very cool. Well, great job, team. I think you also did a great job with your presentation, listening to your user, and agree, like, this is a huge problem and affects like millions of people, and it's having a good quality sleep is really important just for like functioning in life and academics and work. So I really appreciate this. This is great.
Yeah, well done. Thank you.
Thank you.
Thank you.
Awesome. Thank you so much, Team Temper Shirt. All right, and that concludes our student presentations. Why don't we give another warm round of applause to our amazing student teams? Awesome job, everyone. Thank you so much for all of the hard work. And thank you so much, judges. You all have very difficult decisions to make in your deliberation. So again, congratulations to all of our phenomenal student teams, and a huge thank you to the incredible support network of fellows, volunteers, and community members that made all of this possible. So I am now going to send you, Mike, and Prasanna to our pitch deliberation room. And for everyone else that's going to stay here, we're going to have our amazing keynote speaker in a while. So while we're waiting for the keynote speaker, stretch, get some water, and get ready to be inspired. All right. Thank you so much, everyone. So I am going to send Mike and Prasanna to the judging room.
Is there a separate room?
Yes, I am just going to send you to the pitch one deliberation room, Prasanna.
Oh, there you go.
Yeah. Welcome back, everyone. For those that just came back, hello, and I hope you all enjoyed the presentations and pitching. And I know that everybody did such an amazing job. So as we're waiting for folks to come back, why don't we just give ourselves another round of applause for all of the amazing work that y'all have done. Thank you so much for all your efforts and for all of the care that you gave to Project Invent and your amazing inventions. All right, so we are going to, so right now the judges are deliberating and so many difficult decisions have to be made because all of you have such amazing inventions. And I see we have Stephen M. White Middle School students here. Hi, everyone. I see that we have Provision students here. I see we have some of our Project Invent colleagues here as well. Hi, Miss Melton. Hi, Lawrence Middle School. Amazing, everyone. So while we are waiting for our keynote speaker, if anyone wants to put in the chat something that you enjoyed about Project Invent, please do. Or if anyone would like to come off mic and share as well something that you enjoyed on Project Invent. I see a lot of our student teams are coming back. I see East Wake. Our East Wake students here. Hello. I see some of our Stephen M. White educators, Dr. Sikajima. Amazing, amazing. All right. So as we are trickling back, please put it in the chat, or if you would like to come off mic, what is something that you enjoyed about Project Invent?
Hi. So I'm from Stephen M. White, and one thing I enjoyed about Project Invent is just seeing the overall creativity and inventions that all the schools like I've seen pitch, like their creativity, their inventions, and how they're trying to help their community partner.
Something I enjoyed about Project Invent was like the creativity part, because for our project we did have some creative elements and we picked a thing that was really meaningful to us, and it was really fun to do with my friends as well. For me, I feel like it was a nice opportunity to be in project event. Sorry about that. Sorry. Like I was saying, I really felt like it was a nice opportunity to be competing in something like this because it's like, I'm pretty sure second time for me. I don't know.
I'd also like to add on seeing different groups have similar challenges to us, but approach them different ways was really interesting and it helps us learn how to approach things in the future.
It's also cool to see like school from like different places. Like we're from California, and I'm pretty sure there are also a bunch of other teams that are not from California, and it's cool to see what people from other states are doing.
Absolutely. Thank you so much, students, for sharing. And definitely the Project Invent community just has so many inspirational students from all over the country who are so excited and passionate about making the world a better place through invention. And the future is in such great hands with all of you. And we have schools from California, but we have a school from Houston as well. So we have our students from Provision that are here. And we are just really excited to have everyone here. So I'm going to look in the chat as well. And while we're waiting for our keynote speaker, if everyone wants to also get some water, have a little break, please do so. But I'm going to look into the chat and see what our other students have said. So we enjoyed making the prototype. Amazing, Zebulon Middle School. Awesome. And yes, Jerome, definitely a shout out to our North Carolina schools as well. Amazing. I see Provision students, Aria Craft AI Perfume Maker team said, we enjoyed coming together with our classmates with different perspectives. Absolutely. We all have different perspectives, but our commonality is that, again, we're all passionate about making the world a better place through invention. Awesome. So Zebulon Middle School said, yes, enjoyed making the prototype. Creativity, as the students from Stephen M. White Middle School also said. Amazing. All right. So if anyone else has anything to add in the chat about something they enjoyed with Project Invent or where else you want to take your invention to, would love to see it or hear it. All right, again, so I see some of our other colleagues and students are trickling back into our main room. Welcome. Welcome. I see some of my Project Invent colleagues. If my Project Invent colleagues can say hi, give a wave to some of our amazing student teams. Thank you all for your support. All right. So I also see we enjoyed working with our community partners. Shout out to Jerome. Thank you so much, Jerome, for all of the amazing support that you've given to our students. Awesome, everyone. So thank you all for your patience. So like I said, we are about to be inspired by our amazing keynote speaker. So just a sneak peek about our keynote speaker, she is an experienced leader at Google, and she works on something called UX research. So user experience research. I don't know if any of you have heard about what user experience research is or something that you're interested in, but definitely, when our keynote speaker comes on, get your questions ready. Get questions ready about careers in UX design and research. Maybe you're interested in about her career path, her journey to how she got to where she is today, right? Or just any question about or advice that you would like if you are interested in pursuing this. I see a lot of our students at Stephen M. White are like, oh, we want to say something. So it's like, if girls, if any of you want to come off mic and share something else, please feel free to do so.
I want to shout out to our teacher here, Dr. Stephen J. Get in the camera. Go, come on. Go.
Also shout out Mr. Dante since he's our community partner.
Yeah, and Mr. Medrano for making us do this project.
Awesome. Thank you so much, students. And kudos again to Dr. Sikajima, Mr. Medrano, and Dante, your community partner. This would not have been possible without their support and guidance. So appreciate our community partners, our wonderful fellows, and it really took this large and amazing community to make this happen. So we appreciate all of you. We see you all, and we're so excited to work with you all again next year on Project Invent. All right, so I'm just thinking, so is there anything, students, that you learned from the judges in your room? Feel free to come off mic or put it in the chat, but would love to know more. Like, what did you think about the judging portion? Anything you learned?
So for me, especially with some of our judges, especially Melissa, she was talking about how she worked at Intel and how she worked at like a bunch of different places. So like within. So she said she got a lot of experience working with like HR, customer service, like actually like building and designing. So I think what I learned from that is probably like even if you want to do something, like you gotta like you probably also have to like go in like different like places in your field and like figure out what you want to do and get all that experience.
Feels good.
Absolutely. I'm so glad you learned so much from our judges. They're definitely here to support you and to just help you take your invention to the next level, right? So we're really hoping that the feedback and the questions that you got from the judges will help you. And this is just one step on the invention journey. And this is just, again, it's like we've been working on these inventions for so long, but today is just one step of the invention journey. We hope that you all will continue to take this feedback, iterate, test, and continue on your invention journey. So thank you so much for sharing. All right, so I think we have our keynote speaker here, Marian. So are we ready for we're gonna actually get started with our keynote speaker then. All right, so if you all are ready for our amazing and inspirational keynote speaker, can you all give me a heart? Amazing. All right, everyone.
Hi, everyone. Can you hear me okay?
Yes. Hi, Marian. Welcome, welcome. All right. So, everybody, let's please welcome our keynote speaker, Marian Smith. Marian Smith is a super experienced leader at Google, working there since 2021 on something called user experience research. So basically, her job is really making sure all of Google's products are easy and fun for people to use. So no confusing buttons or frustrating experiences are allowed. So Marian is currently on baby bonding leave, but as she returns to the office, she's going to head up a team of researchers who work on Google's AI infrastructure. So that's super important, right? Because the behind the scenes technology is really what makes everything at Google run smoothly. She helps different tech companies figure out the best way to design their stuff so it works great for users. So let's think of her as a coach who helps tech teams understand what people actually need and want. Marian is also really big on making things simpler and better for Google's own developers, and she's always looking for ways to cut down on the number of different tools they have to use so they can get their awesome work done faster and with less hassle. And get this, for fun. So her passion project is super cool. So Marian actually helps out with Google's quantum computer team. So she's using her UX smarts to help design software for these incredible, powerful computers, making it easier for quantum physicists to make new breakthroughs, right? If you all think that's amazing, please just put a heart again. So thank you so much. We're so excited to welcome Marian Smith to Project Invent's Demo Day. Marian, the floor is yours.
Thank you. I am going to share some slides and we will see. There we go. Okay, just bear with me for one more second. Awesome. So, hi everyone. My name is Marianne, and I am a UX research manager, as I was introduced. I got my master's degree in macroeconomics and financial analysis, but I never really practiced financial consulting. So I guess the first thing that I wanted to share with you is that it is okay to change your mind and don't get a job in the degree that you will pursue or not pursue. My mom always said that knowledge you already gained can be stored, but knowledge that you don't have can never be used. I'm not sure if this actually makes sense in English. She always said it in Hungarian, but I think the just comes out. I joined Google almost 14 years ago, back in 2012, and I started my career in sales. That means advertising, but I quickly realized that it was not really my calling. So instead of staying there, I was just looking for something new. Uh, quick question. Can you see my screen or no?
We can see it, Marianne.
Perfect.
Yes.
Yes, perfect.
yeah.
Awesome. Yes, perfect. So I decided to change careers because I started playing Dungeons and Dragons and learned about UX research. So another thing that I wanted to point out, that you might end up on a field that you have never heard of before, and you are never even knew that it existed. And especially now with AI coming along, we don't really know how the future will look like. As I was introduced, my full-time focus is actually on UX research and managing my team. In my 20% time, I volunteer with the quantum computing team. And on my free time, I play with my two daughters. And I also love DIY crafts. And I love to listen to audiobooks. One audiobook is usually fantasy, and the other one is more hard science like quantum physics or psychology or whatnot. Today I prepared 3 short stories for you that I thought that you might learn from. Yeah, it is about collaboration and growth and how to do take feedback from good perspective. So keep an ear open for moral of the stories after each and every one. But before we start, let me give you a little background on UX. At Google, UX is used to build better solutions for those who use our products. We use science to set and test hypotheses, understand user needs and behaviors, and we all work toward a solution that brings together everything we know. My job is to untangle all the chaos that is on the left and lead our engineers to build a simple solution that is on the right. So many people assume that this is how collaboration looks like from our perspective. At the beginning, there's a lot of design, and at the end, there's a lot of engineering. But in reality, our work is much more like this. It's more iterative. It's actually working together and finding solutions and understanding that the first idea is not the best idea. And then we have to go back to the drawing board, design more, and then build it out. And then realizing oh, this is not going to work. Let's go back to the drawing board. And it is okay. So 10 years ago, back in 2016, when I joined the BigQuery team, the team, the UX team was only 3 people. That's a very little amount of people compared to the engineering team that was over 100 people. So I decided in my little head that for that team, UX was not really the frontier. That was not really important. But they did have a plan, because I realized after meeting with almost everyone that they were working really hard on set goals. So because there were so few of us UX people, there were so many things that we needed to do. It was really challenging not to feel paralyzed over the big pressure of everyone wanted something from you. Usability was really new to the team, so there was no foundational understanding of the product use or on where the users wanted to go. So we did have to do some foundational research. I decided to run a design sprint. The design sprint is really exactly what you guys did. Come together, a lot of people brainstorm about the needs of the user, the solutions, design, iterate, but it is in a very short amount of time of a couple days. I invited the product manager whose responsibility was to understand the users, the product, and lead the future of development. The UX designer who drew everything out, the front-end engineering team who built the solution, and the engineering manager who actually came up with the idea of BigQuery. I thought it was a really good collaboration. The sprint outcomes led to more questions, more iterations, more sprint, and there was a big project, BigQuery's Big Future, that was born. I was super excited. I was leading a strategic research. It was early in my career. I was just a junior UX researcher, and I felt like I had hit the ground running, and it was amazing. 1 quarter passed, 2. We were coming out with ideas and everything. And in 2017, we still didn't make it to the engineering roadmap. And I was really confused. Like, we are doing so much work. We are talking to users. The users tell us what they actually needed. And then the engineers just don't want to build it. Like, what's happening? And after years of hard work and seemingly easy fixes that we came up with, nothing. When I had the opportunity to present my findings to the bigger team with the engineering director in place, I was told that I misunderstood the product and the users, because our users were developers, not data scientists or data analysts. So the things that I thought were critical were not really priority for the business. And also, they really just wanted to see a competitive analysis. Competitive analysis is an analysis where you compare your product with other products on the market that have the same job to do. I was thought, okay, like if the team wants a competitive analysis, I'm going to give them a competitive analysis. So in the summer of 2018, see, the years have been passed. Like we started 2016, it's almost 2 years after. On a warm Wednesday afternoon, there was a lunch and learn meeting where people brought their lunches at the table and they listened to other presentations. I had a summer intern who put together a competitive UX analysis, and she presented it. And the presentation was super powerful. Everyone was engaged. The engineers asked questions. Some even stayed after the meeting saying like, oh my goodness, we learned so much. UX is amazing. Can we learn even more? And I was like so happy, like, oh my God, success. And I opened my laptop and I received an email from the engineering director. And I was like, woohoo, impact, yay. He said, there were a lot of interesting findings in the competitive analysis that my intern presented, and that they were very valuable. But in length, he explained how he wanted his engineering team to feel motivated. And when someone is pooping on your product for 30 straight minutes, that is really disheartening. And it's not that they couldn't take constructive criticism. It's just like a call to action is more powerful than a value judgment. First of all, I'm the nicest person I know. And also, I deliberately cut all the positive things because we only had 30 minutes and we were not there to like pat them in the back. We wanted them to understand what they could do, call to action. I was extremely frustrated because in the past 2 years, everything I was saying was dismissed. And I really just wanted to finally have an I told you so moment. Was that so wrong? We all hear stories in our head. They know, one negative thing that I thought about my engineering partners was that they didn't care about UX. And I was proven right over and over again when I saw those evidences that they just dismissed what I was saying. But this is selective bias because you are just selecting all the information that confirms your initial beliefs. confirmation bias. I read that email many times, but only after it lost the emotional charge did I finally get the message. I scheduled a one-on-one meeting with my engineering director because I realized that in the past 2 years, I had aligned with almost everyone but the most important team, the backend engineering team. I had realized during this meeting that had I connected with the director sooner, I likely could have demonstrated the value of pursuing the market opportunity of data analyst and data scientist much sooner. So the moral of the story is your words have weight, but it's never too late to change the tone of your message. Like even if you walk into the room with a clear conscience, pure heart, and good intentions, it is possible that you will push people on the defensive. And if you have an agenda, you will definitely push people on the defensive. So I forgot that I was presenting to humans, that everyone was on the same team and we were working towards the same goal. So I learned so much from this experience. Moving on to story number 2. In 2017, backing up a little bit, my team grew to 5 people, and we got a new product called Dataflow. And since still I was the very first and only researcher on the team, I divided my focus with 50%. Learning from my previous experience, I was very much focusing on building a relationship with the engineering team. So when in January 2021, the VP asked of the engineering team asked like, why is Dataflow's ease of use scores in the surveys are significantly lower than any other products in Google Cloud, I got so defensive. Like, what do you mean? Like, we have an ease of use team. We are working so hard. So instead of focusing on the question that was asked, I started focusing on reasons why the question was out of line. The VP's question was an emotional trigger for me, and I didn't realize this back in the day. I was put on the defensive, and I was trying to defend all the honors of all the people that I worked together with. And to be honest, we always knew that Dataflow was difficult to use, so the survey response was not really a surprise. Long story short, users loved Dataflow when Dataflow worked because they thought it was magic, but it's also a very complex product, and you need to have specific skills to be able to operate it. Apart from Google Cloud wide issues, Dataflow was also very difficult to implement, and as our users' original platforms vary, and it's very time-consuming to debug. Like, yeah, we know. We have been known this for 5 years, and it's a really difficult problem to solve. I could have stopped here because this was the answer to the question, but I went down to the rabbit hole and went down into the troubleshooting nightmares. Since we have been listening to our users for 5 years, we knew about all these issues, and I anticipated the next question, like, what has been done to this? Like, thanks for asking all of this. The team was launching 5 projects in the first semester. This was the point when we realized that the data collection actually answered the original question. Like, yes, it was difficult to use. The reason why our scores were low was because data processing at scale is a very difficult problem. And though we are doing our best with the resources that we have, it's still very difficult. Just like we can't expect brain surgery to be an easy process today that anybody can perform, we also can't expect data flow to be less complex. One day for sure, but now it is not going to happen. So this brings me to the moral number 2. There are always more sides to the story. In my previous one, I highlighted how I did all the research assuming alignment and felt frustrated when my recommendations were deprioritized. In this story, I had extreme empathy towards the engineers and were ensuring them at all times that they were doing a great job. I was emotionally invested in their journey, and when someone dared to ask me the question, I jumped to defend them without giving that reaction a second thought. So be confident. Know that you're doing the best that you can with the resources that are available to you, and Assume the same from others as well. With that perspective, you will see the big picture, will avoid unnecessary time spent on defending yourself and your work or your team. Ultimately, our job is to tell the story of today to help our partners, our teams build the solution of tomorrow. So UX researchers like me also have a big advantage. Like we have done the research, we have all this knowledge, all this context that other people don't. So when we walk into the room, there's this knowledge gap that often is invisible to us. So we feel frustrated that the other person doesn't understand what we're talking about. Which brings me to moral number 3, focus on the facts and the big picture. Remember that others don't have the amount of information that you have, and it's not obvious to them that your conclusions are valid. So take them on a journey, walk them through your process, walk them through your data if that's necessary. You did what you found for a reason, and you're telling a story for a reason. But the information is more important in a sense of what does it mean to everyone else around you in the room. Focus on growth and innovation, and be aware of the story that you're telling to yourself, because it might not be the full reality. Okay, story number 3, and then we will be done. In 2020, I started working together with the Flume team. Flume is the internal team. It is just for Googlers. This is a product very similar to Dataflow, but it's for internal. The research was a success, and I got another request to work together with the engineering manager. So we ventured out on something that is called need finding. The new manager was very engaged and motivated to build the right thing, so we immediately aligned on this new goal. He showed me the product requirement document that he drafted, and we formed a hypothesis together. More teams will use live data that was provided by Flume if the service is cheaper. Obviously, like if something is cheaper, more people can afford it. He put together some interview questions. I put together some interview questions, and we interviewed 25 different teams, wrote 40 pages of research findings, and presented it to different teams. It was an impactful project because we found something none of us expected to find. We learned that real-time data processing was, back then in 2020, not an immediate goal for the majority of our customers. Teams wished to modernize, but they wanted small steps compared to giant leaps. So users were looking for solutions that were easy to use and adopt, that fit into or at least built upon the existing infrastructure and mental model that they had. So this brought us to this really cool realization that a Moonbase, which was Flume on Microbatch, is much better than streaming Flume, which is like a colony on Mars. The message was also very important to be structured in a way that is not triggering to people, because there were a lot of people working on streaming Flume, the ultimate goal of the colony on Mars. And we wanted to make sure that they don't feel threatened or anything. And their job is safe. It's just like we need to build a bridge between these two structures in the immediate term. So the moral of this story is when we, the team, are doing our research, it's a whole new level of impact. Like when you as a researcher does the research, that's different than when we, the whole team, is focusing on the same problem. It took me a while to understand that being a researcher didn't mean that I was the only one who was allowed to ask questions at research interviews. And it also took me a while to learn how to collaborate and how to co-create in a space where individual work provided more visibility and better evidence when promotions were considered at the end of the year. But once I put down my fear of missing out in a recognition, I was able to become the research partner my team actually needed. And guess what? We even had more and more impact at the end, and I got even more recognition. So the big lesson for me was understanding that I was enough. You see, I grew up with the family programming of always be your best self, but never be full of yourself. Again, this might translate very funny in English because it's a Hungarian saying. Uh, but while the best self is impossible to define because best is a subjective term. It's like best compared to what? And the second half of the marching order, don't be full of yourself. Like set invisible boundaries around this set best self, like suggesting that best and full are measured on the same scale, and there's only like a really thin line between that. So be careful how you create the story and self-image in your head, because it was difficult for me to accept this as an area of growth, because my ego did a pretty good job justifying my actions and putting me defensive monologues. But here's the thing, I'm not perfect. No one is, no team member of yours, no one. But my subconscious mind jumped to conclusions, and I felt the need to defend me against the pre-programmed feeling that I wasn't enough. But I am enough and you are enough, and what you do is more than enough. In every moment of every day, you and me, we are doing the best we can with the resources that are available to us. So I decided I needed a new mission statement, something that's grounding and realistic, yet motivational. So I came up with this one. Always be your authentic self, and everything will fall into place. So the final moral I would like you to hear is this one. Just because I am right, that doesn't mean that you are wrong. Just like how we help others grow and become a better version of themselves, people around us would love to return the favor. It's often difficult to receive constructive feedback gracefully, especially if it's delivered in a way that's triggering. But remember one thing, and this is like just if you'd remember one thing from this entire presentation, just this one. It's not other people's job to tiptoe around your emotional triggers. It's your job to work on yourself and evolve as a human being. So there you have it. These are my principles for work, the principles for growth. It doesn't matter what process you use. What matters is how you frame and tell your story. It's okay to get defensive, but recognize that you did and breathe out all your fears. Everything will be fine if you work closer together with your team and co-create your vision together. And don't forget that just like others, you are also constantly growing. It's only natural that we have blind spots, and it's a privilege when someone feels safe enough in our presence to share their feedback with us. Thank you.
Thank you so much, Marian, for that wonderful presentation and for sharing your stories, your tidbits and wisdom. And we're so excited that you're here, and thank you so much for joining us. So I would like to turn it over to our students. So students, do you have any questions for Marian? If so, you can put it in the chat or come off mic.
Oh, you're welcome, Medicine. And also, I see that there was a D&D very cool shout out. Yes, it was very cool because that's how I learned about UX in general. I started playing with a dungeon master who was a UX designer, and he said that I should transfer into UX research. And I was like, what is that? And the rest is history.
So, how did you learn to work with others did it happen over time, or like did it like require you to put in some effort?
How to work with others together? Yeah, it required a lot of time. I have been working with other people for 15 years, And it started out like, oh, I'm doing my own job and this is my responsibility. And whenever someone wanted to help me, I was like, no, this is my responsibility. These are mine. This is mine. And it took me a long time to understand that it's okay to let other people help me. It's okay to let other people step in. It's not that I will do less work. It will be just like together we will accomplish more faster.
If you were in middle school, did you like doing group projects with other people?
So I grew up in Hungary. In middle school, we did not have group projects. I only started doing group projects back in university. And I actually really loved working together with other people because we had a really good team. Everyone did their fair share. We started our projects always to just like lay out like what needs to be done, and then people claimed different parts of the project, and we came together after a while to just work together. Yeah.
Thank you.
Yeah.
Do you think you definitely improved on like overall just working together with like your group and just like group projects in general?
Yes. So every project that you will ever do in a work setting, especially if you are not doing your own small business, but maybe even then, will be a group project. There will be other people involved. And it is a learning curve to set up processes. There are so many methodologies out there, how to keep in line, how to stay on time, what to do first, what to do next, and you just have to learn what works for you because not everything works for everyone. So yeah, it is a learning curve. It's a big learning curve for sure. And also, there are those people who are slackers who you think will provide or do something, but they don't. And sometimes it's not because they didn't want to do it, it's because of circumstances that are outside of their control. Uh, the raccoon ran in and ate their homework or something like that, you know. Or they fell ill, they broke a limb, they were in a hospital. Hope not. But yeah, it is very important to find a group dynamic that works. And you know, another thing is that every time you feel like, oh, our team is now performing and we are just doing everything and it's muscle memory, a new person will join the team and you go back to zero, and productivity will plummet, and there will be interpersonal relationship differences, like more arguments, more fights, weirder feelings. But over time, it will work out itself, and it's like ups and downs all the time.
What would you tell your younger self about STEM science?
Always stay curious, and the best thing about science is that it always changes. So do not stop reading books. Do not stop listening to scientists, because what they do is test their hypotheses, and what works, they accept. What doesn't, they reject and let go. And just because some people think about things and they tell you stuff, that doesn't mean that it's correct. But be humble enough to be able to listen to all perspectives, but always test and always try and experiment.
Thank you.
Awesome. So, do we have any more questions for Marian? Okay, I see we have one more from Stephen M. White. Go ahead.
I think they were just doing thumbs up.
Thanks, Marion. All right. Well, thank you so much, everyone. Thank you so much, Marion. So, students, community members, why don't we give Marion another warm round of applause for all of those amazing tidbits, her journey, her experience, her knowledge. Thank you so much, Marion, for joining us today. We appreciate you so much. Awesome. So, everybody, now the time has come for our award ceremony. Are you all excited? Yeah, I see a lot of thumbs up there. All right. So before we announce the award winners, I would just like to share about our awards, and they're all based on our student mindsets, right? So, the judges are awarding student teams based on how they grew across Project Invent during this whole process. Whether you're a team that really demonstrated that you set high goals, or you were really able to hone in on the challenge raised by your community partner. Did you fail? But what did you learn? As well as creative confidence. All right, so today our judges will be distributing awards to teams. These awards, and they are the Need Finder Award, so given to a team that really listened to their community partner. The Product Pivot Award, given to a team that had to overcome many challenges and obstacles. The Moonshot Award, given to a team who identified and created a notably creative product, as well as the Explorer Award, so presented to a team that demonstrated a significant amount of learning throughout this journey. Now, again, before we begin, students, we would just like to say that you all deserve a very warm round of applause, because what you have done during this demo day and throughout the year and the months is so incredible, and a lot of hard work and innovation was demonstrated today. You've really learned the skills to become fearless and compassionate problem solvers of tomorrow. So, if you do receive an award today, that's exciting. But if you don't receive an award today, it is so far from the end of your journey. We're so proud of you. And with that in mind, I would like to welcome back our judges. We're going to do it per room. And so I would first like to call on Prasanna and Mike to present the awards for room 1.
Thanks, Amanda. I'm going to present the Explorer and the Need Finder awards. So this first award, this goes to a team that did a really great job of listening to their community partner. They pushed themselves to include multiple sensors in their prototype, and they did that to address the need of saving energy. They created multiple prototypes, and they did a fantastic job of incorporating their community partners' feedback to improve each version. So the winner of the Explorer Award is Team All-in-One. Great job, team. We really appreciate you. And the next one. So this team also, oh, sorry.
Thank you so much.
Yeah, great job, team. Sorry. No. That's great. You are welcome. You earned it. You earned it. This next team also did a great job of listening to their community partner and coming up with a product to address all of that community partner's needs. They also worked through multiple prototypes to ensure that they found a solution that really worked for their user. So the Need Finder Award goes to Team Temper Shirt. Great job, team.
Thank you.
All right. So the next award is a Product Pivot Award. This team's first invention literally hit a wall when the coding completely broke down. Instead of giving up, they pivoted to a brand new approach, built a lumen sensor, and that actually works, and even tested it out in their counselor's classroom. And that kind of grit is exactly what this award is all about. Congratulations, Team Light Saving Movement.
Thank you.
All right. Congratulations. You guys did a really great job. The second or the last award in our category in the first batch is the Moonshot Award. This team designed a robot that travels inside water pipes, detects leaks, and also sprays sealant to stop them, something no product on the market does today. They built a working prototype. The 3D printed, the final design was amazing, and even got a feedback from the county water department. That's a big, bold idea. The congratulations, team Leak Hunters. You guys did a really great job. I really loved the demo you guys showed us.
Thank you so much, Prasanna and Mike. Congrats again to Team Leak Hunters, Team Light Saving Movement, Team Temper Shirt, and Team All in One. Let's give them all a warm round of applause. Awesome, awesome, everyone. Okay, pitch room 2. Are we ready, judges and students? All right, so I am going to call on Swati and Timothy to present the awards for their room.
Okay, Swati, I'm gonna let you present these. I just want to make a comment at the start, if that's okay.
Okay.
So just for all the teams, we had 6 teams that presented. So just wanted to tell all of you, we thought you all did a really good job, and I know this is tough and it's challenging. And since not everybody wins award, doesn't mean the fact that you didn't do a good presentation or that you didn't do good on your projects. We just had so many that we could pick, and it was kind of a tough thing that we went through and selected our solution. So I just want to congratulate everybody on the time and the effort that they put in, and just want to say good job to everybody of the team that was in our session.
And I will echo that, and I will also say thank you to all of the teams for answering our questions to help us better understand your journey in the whole product ideation and solution. So thank you for that. And so the 3 awards we chose from amongst the 6 teams. The first one was the Explorer Award, which really focuses on the prioritized learning. And our winning team in this case was Team 5.
I have their name.
Yeah, Auto Cook and Chem Detector.
It was the Brit.
What we really loved about them was this is the team that thought about the challenges in teaching Braille to a blind person, but they also thought about how to teach people who are not blind Braille, which was a really good thinking on the product. We definitely saw them demonstrate learning on the evolution of that prototype, thinking about the future facing challenges as they evolve that product. So the Explorer Award goes to AutoCook and Chem Detector. The next award is the Need Finder Award, where you really listened to your user. And that's an important part in any product, because in the end, the product has to be a viable option for the end person. And we kind of tossed around on the team. They were good presentations. We finally chose team 2, which is Better Pipe. And they were looking at the drains being clogged, We thought there was thoughtfulness done in both the product ideation and about where the product would evolve. So there was good future thinking. Definitely saw them work with the community resource as well as their teacher. Just a lot of the qualities we were looking at. So that was Better Pipe. The third one is the Product Pivot Award that we selected, which really goes to someone that overcame obstacles, but stayed resilient and continued to work on their product. And that one goes to Team Above the Water. And we thought their concept was good, how they evolved. That concept was great as they faced challenges. It took them time to get the research, but they faced their hurdles and continued to look at it. Loved that they looked at cost efficiency. So that was sort of thinking about how do you take it to market, and made sure they got feedback from their community partners. So their user was also providing input and it was not done in isolation. So congratulations to all three teams. Above the Water, Better Pipe, and AutoCook and Chem Detector.
Nice job. Your check's in the mail.
Thank you so much, Swati and Timothy, for being our judges for Room 2. A lot of difficult decisions were made just now, and congratulations to all teams, but also to our Room 2 pitch winners. Again, let's give them a warm round of applause. All right, everyone. So we are going to move on to our last and final pitch room and the winners. So I am going to call on Melissa and Artilia to announce the winners for Pitch Room 2.
Great. First of all, I want to recognize and really just appreciate all the teams that pitched today. I love seeing the curiosity, the ideation, and just the iteration that everyone did on their prototypes. So I'm announcing 2 awards. The first award is the Need Finder Award. What we really appreciated with this team is they listened to their community partner. They made the product fun and very usable. They received feedback not only from staff at the school, but also from students. And so the Need Finder Award is going to go to Sanrio Clowns. We really loved how they input their feedback into their future ideation and their future prototypes. And then the next award I will announce is the Explorer Award. We really appreciated this team's ability to learn everything about water pressure, about different size pipes, about the ozone layer. We liked seeing the evolution of their prototype and how they really had answers to some of the questions we had about how they were iterating and kind of implementing their future product. And so this award is going to go to Team H2O. So I want to thank all the teams and congratulations to Team H2O and Team Sanrio Clowns.
Awesome. Congratulations to all of our teams. Congratulations to everyone that participated, but also especially congratulations to the winners of Pitch Room 3, Team Sanrio Clowns and Team H2O. Let's give ourselves a warm round of applause. So exciting. Thank you so much. Congratulations to everyone again. All right. So before we close our event today, we are going to get a group photo. So we would love to see all of your beautiful faces on screen if possible. Fix your hair, we're going to get started soon. So please turn on your cameras and we would love to see you all. All right, everyone. I see our Paul Revere Middle School students are ready. Our Stephen M. White Middle School students are also just like ready and pumped. All right, we have our East Wake students getting ready. All right, thanks, Mr. McKenzie. I see you there. Thank you so much. I see our PVA team warriors here. Lawrence Middle School students, where are you all? All right. Okay, everyone. So on the count of three, please give me a thumbs up if we're ready to, first of all, to take our photo. Are we ready, everyone? Okay. All right, everyone. So on the count of three, I'm going to take our photo. Okay, big smiles. One. Okay, Sarah Lawrence Middle School students still getting ready. All right, everyone, come on. All right, all right, all right. I see everyone's smiles are ready. Our poses are ready. So I am going to take our photo at the count of three, okay? One, two, three. Awesome. One more. Can y'all give me a heart or a peace sign or a thumbs up? Okay. One, two, three. Amazing, everyone. Okay, thank you so much. So we are going to be sharing this with everybody. Okay, so congratulations again to all of our winners and our amazing student team. So before we go, if you are all inspired today by all of the amazing inventions, creativity, and work that our student inventors have done today, come donate to empower our young inventors. So any amount is highly appreciated. So if you are inspired and want to donate to fuel the next generation of change makers, scan the QR code, or you can also reach out to our amazing Project Invent team to learn more. And with that, our event is closing today. So congratulations again to all of our amazing teams today, and a huge thank you to our judges and our keynote speaker, Marion. Thank you to the Project Invent team and also for the incredible community for making this possible. So let's give one more round of applause to everybody here today. Thank you so much, everyone. And with that, our event is going to close. So again, thank you. And I hope you have a great rest of your afternoon or evening from wherever you all are calling from. And we appreciate you so much. Thank you, everyone.
Thank you so
Thank
much.
you.
Thank you so much. Thank you.
Thanks, Shab.
Bye, everyone.